A while back, DHH recorded a screencast to show off ActionCable for Rails 5, to show what it was like to create a WebSockets app with Rails 5 and ActionCable. And so I wanted to show that that is probably a bit more than most WebSocket apps will need. For the most part, generally people want WebSockets to send some data, just send some data from the server to the client. In fact, that's Pusher.com's entire business. Well, now with the exception of their push notifications that they just released. So let's try and come up with something that's a bit simpler than that. So there's a WebSocket app in Rails just needs to have something mounted in the router that's just a simple object that responds to call. That's all you really need. You just need to be able to mount a rack app that responds to call. And so here we have a rack app that responds to call. All it is just a simple plain Ruby object that has a list of WebSockets that we're going to use. When we get a WebSocket connection, if it's a WebSocket, then we make a WebSocket out of it, a WebSocket object, shovel it into the array, and when we get messages in, we get the message out of the message event, and then send that message across all of our WebSockets that we have connected. And then when the WebSocket disconnects, we just remove it from the array. So so we've got that mounted, and we just need to open up a WebSocket connection to somewhere on our server. And so we're just going to do that at /chat messages, just for whatever. This is a file that we'll come back to in a minute. And this is our front end app. This is a Clearwater app, and Clearwater is, for all of its front end, for all the front end stuff, Clearwater runs through Bowser. Bowser is a browser abstraction for Ruby on the front end. So it lets you use some of the browser APIs from Ruby. So what this does, so this is our layout component. It's really the only component that we have for this particular app. It's just a Ruby object that includes the component mixin. When we instantiate it, we need to pass in an array of messages that we're going to render and a WebSocket that we're going to talk on when the user presses the enter key inside of this text box. And so, relatively simple stuff if you're familiar with HTML elements, really. Get a div, an h1, the list of messages, and so it's the messages that got passed in up here to the initializer, and we're going to map over those and put each one of them in a list item. And that's really all that means. And then we have this input, which is just this text box. We're going to go ahead and autofocus it because it's a chat app. So usually you want that autofocused when you load it up. And every time you press key, we're going to call the handle key method, which it's just a method, takes in the key press event, and if they press the enter key, we're going to get the message out of it, clear it out, and send that message off on the WebSocket. Now that's all just in a class. Like the app, at that point the app hasn't even run yet. So now we get into the code that is actually executed on boot. We initialize the messages array, brand new empty array. Open up a WebSocket connection to our server, which is just WebSocket localhost 3000, and at that chat messages endpoint that we declared over here in the router. So those two have to match up. and then we make a Clearwater app. We actually instantiate the application. Its its root component is this layout component with this messages array and this socket. And then we go ahead and invoke the app once it's instantiated. And then we also want to make sure that whenever we receive a message on this WebSocket, that we go ahead and append it to this array, just kind of shovel it in there, and then re-render the app. And so that's it. Like that's the end of it. That's all there is. That's the end of the app. And now, I mean, let's go back to our server here, and we're gonna go ahead and we're gonna send it a message on in this text box, which is gonna invoke this on message handler, which is then going to send it back out. Remember, inside the front end app, we don't actually, like when we get the enter key, we're not adding it to the messages array anywhere in here. We're sending it out on the socket and then waiting for it to come back from the server. So we actually have to have verification from the server before we re-render it, before we render it into the list of messages. And so if we reload the app, we can see we're actually getting these messages back. It's not super simple. Essentially, it's like when you're dealing with two-way WebSockets. Like this is actually bi-directional WebSockets, so we're receiving messages from the client to the server and from the server to the client. Instead of the typical client-server request response paradigm that most of us are probably used to on the front end, or on the web rather. So the problem with this is very simple. The problem is because this is running in an array that's not backed by anything that talks to any other machines. If we're running this on multiple servers, then that's going to be problematic. We're not going to be connected to every single other person that's using our app. And we can see that here. I've got multiple windows open, and we can see that if we load up, wow, none of these are connected to each other. There we go. Two of them are connected. These two here. And so that's the problem of running it on a single machine that uses just an array in memory. And so DHH mentioned something about using, oh, looks like it's connected over here too. So these three, this one here on this page, and these two over here are connected. But those are the only ones that are connected to anything else. These over here aren't connected to anybody else. Not even each other. So what we end up needing to do. So DHH mentions using Redis pub sub for this stuff, and I'm going to show you how not difficult that is. It's a little confusing at first because you have several different things working with each other, but it's not a lot of code. So the first thing we need to do is we need to take in a Redis instance and a channel to talk on for the Redis pub sub. And so we're just going to go ahead and store those on the object, and we're going to add some convenience methods here. Now also we need, inside of here, we need to, instead of sending it off over all of the sockets that we know about immediately, what instead we're going to do is pass it off to a chat message worker, some background job that will handle publishing on our Redis channel here. And then after that, we're gonna need to listen to subscribe to those updates from Redis, which will then send off the messages. Remember, this was up here before, and now we're sending it out when we receive word from Redis instead of sending it out immediately. So this is what's going to connect all of our all of our servers together for the WebSockets. But now we need to run we need to run this in a separate thread. We need to run this listen method in a separate thread because this blocks. This is blocking I/O. We can't run this inside here. So what we need to do is start this up over here. And you notice this isn't message handler dot new. This is message handler dot instance. And that's because we need to connect it to the same one being used in here. Inside the routes, we need to make sure that the message handler that we connect to when we come in over the chat messages URL is the same one that's listening here inside of this Ruby process. So we need to use only a single instance. This is called a singleton. And so we just go ahead and define the instance method here. We don't want to enforce it as a singleton. There's actually a Ruby singleton library for this in the standard library, but we don't want to enforce it. We just want to make sure that it's possible to do. It's easier to test if you don't actually use a singleton and you still allow instantiating objects on their own. And then let's go ahead and save all these off. Oh, first let's look at this. So this is the worker that we delegated off to. So inside of this is a Sidekick worker. I'm using Sidekick, not just active job. But so we actually insert the message into the database, which is not something that you want to do inside of your message handler here, because if for some reason there's a blocker, like the row is locked or the table is locked for any reason whatsoever, you don't want to block this. You can block this background job all you like, but you don't want to block your request handlers. So we insert that into the database here, and then we kick off the Redis publish command, which is what we're listening to in our listen method, which is running inside of a separate socket, or a separate thread rather. And so we're kicking that off from the background job with Redis, with Sidekick. Sidekick's Redis connection. And that was actually the reason I chose to use Sidekick, was because it's already got Redis going instead of just using active job. I'm not sure what active job uses. So if we reconnect here, let's go ahead and reconnect all of these. And now they're all connected up together. Now just let's go for a bit of a recap on how the flow of messages here. It goes from the front end app to the message worker, which then sends it back out to Redis, which gets picked up in the message worker again. It gets picked up here, and then sends out the message on to all of the sockets, which then gets picked up back in the front end app here. So it's a little complicated. There's a lot of data. The data is flowing through a lot of different points. If you don't need all of your servers connected to each other, then you can just do this in a single process, the way we had it going in the beginning here, which is just if you're doing a chat app, you're going to want them connected as much as possible. So using Redis PubSub is a good approach there. But if you're just doing it with connecting directly from the client to the server and back, you don't need anything more complicated than this. So that's my demo on Clearwater and WebSockets without ActionCable. I hope you enjoyed it.